Good day everyone, I'm Vignesh Armugam. Today I would like to present my research paper under the title of Synthesizing Green Chitosan Magnetic Composite Particles from Phaneropic Discus Species for Palm Oil Mill Effluent Pretreatment. Introduction. A variety of studies has been conducted with different forms of coagulant and flocculant on the treatment of POMI. Coagulation and flocculation are used in wastewater treatment to isolate the suspended contaminants from water. In recent years, natural organic coagulant have been used as environmentally safe coagulant in wastewater treatment. Natural organic coagulant are environmental friendly products that are biodegradable and are made from organic waste such as prawn shell waste. Chitosan is a high molecular weight cellulose-like biopolymer obtained from chitin deacetylation and was used for wastewater treatment application. At present, magnetic particles are widely studied in the area of water treatment. The fine size effect and high surface to volume ratio of magnetic particle result in increased adsorption capacity. Chitosan and magnetic particle are interlinkable to satisfy the needs of high adsorption, regeneration, fast separation, and cost-effective treatment of wastewater. This study has been conducted as it provides a greener environment to society in the long term. Chitosan magnetic composite particles create greener energy and help develop an environmental friendly waste management system to minimize the environmental pollution. These chitosan magnetic composite particles are reinforced in the pre-treatment process for better agglomeration, adsorption, coagulation and flocculation of POMI. Objectives: synthesize chitosan magnetic composite particles from prawn shell, analyze the wastewater quality parameters during startup and end-up period. The wastewater parameter included chemical oxygen demand, ammoniacal nitrogen, turbidity, total suspended solid, and also pH value. Obtain the adequate dosage of coagulant needed to optimize the wastewater parameter reduction. Methodology. Methodology consists of three parts. First will be the extraction of chitosan from prawn shell using deproteinization, demineralization, and also deacetylation. First will be deproteinization. Deproteinization where use low concentrated of sodium hydroxide to remove the protein, which is a tertiary structure of the shell. Followed by the demineralization where use the hydrochloric acid to remove the minerals or inorganic compounds such as calcium carbonate. Last but not least will be deacetylation where use high concentrated of sodium hydroxide to remove the acetyl group and form the amino group. So at the end of the process, the chitosan will be extracted. Part 2 will be the synthesizing chitosan magnetic composite particles. Here use the iron 2 plus and iron 3 plus ion solution and well mixed with the chitosan solution. And the chemical co-precipitation method begin by adding the sodium hydroxide dropwise to synthesize the composite particles. Part 3 will be the POME pretreatment. Here I analyze the wastewater parameter and also identify the optimum dosage level of the coagulant which achieve the maximum reduction of all wastewater parameters. Result and discussion. Chitosan magnetic composite particle synthesis. In this study, chitosan magnetic composite particle synthesis was prepared in two stages. First will be the chitosan extraction from the prawn shell, including deproteinization, demineralization, and also deacetylation, and the co-precipitation process in the presence of chitosan. Chitosan exists in the form of pale pink, which was converted into powders. The degree of deacetylation was tested for chitosan as one of the key parameters, and the DD level of the chitosan was 84.93%. Besides, the chitosan solubility in 1% of acetic acid was 82.2% with a pH level of 8.32. The moisture content found in the extracted chitosan was 5.181% with a yield of 81.7%. Furthermore, the composite particle was synthesized in a good quality of the range. The yield and moisture of this composite particle obtained were 92.63% and also 5.05% with a pH value of 8.17. Wastewater quality. First, POMI parameter was identified before the jar test has been conducted, which is known as startup period. Whereas the end up period, the POMI parameter was identified after the jar test has been conducted by using the chitosan and also the composite particles. And the wastewater parameter included the pH value, turbidity, TSS, amoniacal nitrogen, and also the COD value. The last part will be the dosage of coagulant needed to optimize the wastewater parameter reduction. In this analysis, the impact of various parameters was investigated. For the coagulant dose, around 16 analytical experiments were performed for both composite particle and also chitosan. In this experiment, the optimum dosage of chitosan magnetic composite particles that needed to achieve the maximum reduction on wastewater parameter was 4 gram per liter, whereas for chitosan was 5.5 gram per liter. Optimum dose of 4 gram per liter, this composite particle decreased the level of all the wastewater parameter. But chitosan, on the other hand, seems to require a little more dose, which is a 5.5 gram per liter, to achieve the maximum reduction in all wastewater parameter. These graphs show the wastewater parameters against the coagulant dosage, which is the composite particle. If coagulant dose increases, it does not affect the wastewater parameters reduction much, but it slightly reduced. This is because the coagulant achieved its limitation on POMI pretreatment process. Conclusion. In the presence of chitosan, the co-precipitation method of magnetic particles was used to synthesize chitosan magnetic composite particles as a coagulant for the POMI pretreatment. Optimal dosing of 4 gram per liter chitosan magnetic composite particles was reduced the turbidity, total suspended solid, ammoniacal nitrogen, and also the chemical oxygen demand by 94.6%, 89.2%, 63.8%, and also 90.6% respectively. This composite particle is environmental friendly and sustainable to use in POME pretreatment process. These composite particles in the POME pretreatment cycle improve the efficiency of agglomeration, adsorption, coagulation, and also flocculation process. That's all from me. Thank you so much for your time and attention throughout my presentation.